In the heart of the Cold War, as the world held its breath while the United States and the Soviet Union raced each other in every domain, from space exploration to nuclear armament, there emerged an ambitious, awe-inspiring marvel of Soviet aerospace engineering that sent shockwaves through the aviation world. The Tupolev Tu-144. Nicknamed Concorde-ski by Western observers for its striking resemblance to the Anglo-French Concorde, the Tu-144 was not just an aircraft. It was a bold political statement, a declaration of Soviet supremacy in the skies. Unveiled to the public in the late 1960s, the Tu-144 became the world's first commercial supersonic transport aircraft to break the sound barrier, achieving Mach 2 speeds and soaring to altitudes beyond the reach of most commercial jets. But what truly made the Tu-144 iconic wasn't just its speed. It was its radical design and intimidating presence. Starting from the moment you laid eyes on its futuristic, needle-like nose that could droop forward during landing for enhanced pilot visibility, and retract for a streamlined supersonic profile. Unlike anything else in the sky, the Tu-144 featured retractable canards, small forward wings near the cockpit, used to improve lift and handling at low speeds, extending dramatically during takeoff and landing like the talons of a predatory bird preparing to strike. These aerodynamic features weren't just for show. They were born out of necessity to overcome the engineering challenges of flying an enormous 350,000-pound aircraft at twice the speed of sound. As you walked around the Tu-144, its polished, sharp-edged fuselage gleamed like a sword in the sun, its delta wings stretching wide and sweeping back with deadly grace, whispering promises of speed and Soviet ambition. The four colossal Kuznetsov K-144 engines mounted beneath the wings roar with immense thrust, engineered to propel the aircraft to over 1,300 miles per hour, with afterburners that lit the sky like a missile launch. But stepping inside the Tu-144 revealed a different world altogether, one that felt more like a prototype laboratory than a passenger jet. Unlike the Concorde's refined leather interior, the Tu-144's cabin was stark, functional, and minimalistic, packed with hard surfaces, rigid seats, and narrow aisles. Soviet engineers prioritized speed and performance over comfort, and it showed. Walls were lined with exposed panels. Overhead compartments were small or non-existent, and the air carried a faint scent of heated metal and jet fuel. The cockpit, accessed by a narrow corridor up front, was a cathedral of analog dials, switches, and glowing indicators, designed for a crew of three, pilot, co-pilot, and flight engineer. With over 1,000 switches and gauges, managing the Tu-144 in flight required military-level coordination. It was less a commercial airplane and more of a supersonic testbed that happened to carry passengers. The droop nose mechanism was a spectacle in itself, lowering down like a mechanical beak during approach to allow pilots a better view of the runway. It could be retracted in flight for optimal aerodynamics, controlled by a dedicated lever in the cockpit linked to hydraulic systems. The forward canards, usually tucked flush into fuselage mid-cruise, extended outward with a whirring sound, stabilizing the aircraft during the lower speed phases of flight. Watching the transformation of the Tu-144 during takeoff or landing was like witnessing a robot morph into a different machine, parts shifting, wings flaring, nose descending. It was magnificent and surreal. But the Tu-144's legacy wasn't without turbulence. Despite beating Concorde in both first flight and first supersonic flight, the Tu-144 was plagued by reliability issues, vibrations at high speeds, and tragically, a catastrophic crash at the 1973 Paris Air Show that severely dented global confidence in the aircraft. The Soviet government pushed ahead regardless, determined to showcase the USSR's aerospace prowess, and for a brief time, the Tu-144 did enter limited passenger service. However, its commercial run was short-lived, just 55 scheduled flights in total, hampered by high operating costs, technical difficulties, and a cabin experience far inferior to Western standards. Still, the Tu-144 continued to fly in various forms for research and training purposes, especially into the 1990s when NASA and Russian scientists partnered to use a modified Tu-144LL for supersonic transport research. The aircraft, stored now in museums and airfields across Russia, remained a monument to Cold War ambition, technological courage, and the raw audacity to defy what seemed possible. From its sci-fi profile and blazing speed to its strange dual identity as both a passenger aircraft and military-grade machine, the Tu-144 was never truly understood by the public, but it was always respected. Engineers around the world studied its design, admired its breakthroughs, and learned from its failures. Unlike the Concorde, which symbolized luxury and Western elegance, the Tu-144 was about brute force, speed, and pushing boundaries with sheer will. Even today, when aviation enthusiasts gather around preserved Tu-144, there's a sense of awe in the air, a quiet reverence for a machine that, for a fleeting moment in history, flew faster than any other commercial aircraft, blazed trails to the stratosphere, and reminded the world that the Soviets, too, could chase a horizon with thunder in their wings. The sound of those mighty engines, the way the canards extended and retracted like a predatory raptor in flight, the iconic droop nose lowering before touchdown. It all lives on an aviation legend. The Tu-144 wasn't just a plane. It was a symbol, a risk, a dream wrapped in titanium and jet fuel. It was the Soviet Union's fiery response to the West Concorde, a supersonic fist through the sonic wall. And though it burned fast and fell early, it lit the path of those who would come after. As we look back now, from a world dominated by subsonic airliners and hypersonic dreams, the Tu-144 remains frozen in time, a magnificent beast that dared to go farther, faster, and louder than anyone thought possible. Yet behind the roar of those massive afterburners and the razor-sharp silhouette slicing through the skies at Mach 2, the Tu-144 carried with it more than just passengers. It carried the burden of geopolitical symbolism, national pride, and a relentless race for technological dominance. It was built in secrecy, tested in extreme conditions, and deployed with urgency, all under the veil of Cold War pressure and propaganda. Inside Soviet design bureaus, engineers worked day and night, not only to keep up with the West, but to overtake it. The Tu-144's development was accelerated to such extremes that mistakes were inevitable, and in many ways, the aircraft was rushed into the skies before its time. Still, the effort was Herculean. At a time when data was analog, material science was evolving, and the understanding of supersonic aerodynamics was still in its infancy, the Tu-144 engineers pushed boundaries with a stubborn kind of brilliance. They created custom alloys to withstand the frictional heat of supersonic flight, invented cooling systems to keep onboard equipment from frying at high altitudes, and solved stability problems by adding retractable canards, something no other commercial aircraft had ever tried. The droop nose, a marvel in its own right, wasn't merely for aesthetic flair. It solved a crucial visibility problem during landing approaches, when a high angle of attack on Delta Wing aircraft created a dangerous blind spot. The nose was hydraulically actuated, controlled by cockpit systems that allowed it to tilt downward by 12.5 degrees, enough to give the flight crew a clear view of the runway. The engineering challenge of integrating such a mechanism into a supersonic airframe was enormous, but the Soviets didn't flinch. They delivered, and the results were breathtaking. As the Tu-144 soared across the stratosphere, it left behind a trail not just of vapor, but of awe and disbelief. Civilians, reporters, and even enemy intelligence analysts couldn't look away when the Tu-144 took to the sky. It was that compelling. On the tarmac, crowds would gather to watch the aircraft extend its front canards, like a beast awakening before launch. When the wheels lifted off the runway and the fuselage cut through the air with that unforgettable high-pitched wail, it felt like humanity had skipped a step and jumped right into the future. And yet, for all its visual drama, the experience aboard the Tu-144 was something else entirely, something that felt unfinished, raw, even a little dangerous. The cabin was cramped, often uncomfortably hot, due to limited insulation against the heat generated by air friction at supersonic speeds. The windows were small and oddly placed. Seats were rigid, and passengers were often subjected to loud engine noise for the entire duration of the flight. There were stories of overheated meals, of drinks vibrating off trays, of announcements barely audible over the roar of jet engines screaming at 60,000 feet. This wasn't luxury. It was raw, unfiltered speed with no apologies. But to the Soviet elite, this was acceptable. It wasn't about the in-flight experience. It was about what the aircraft represented. The message was clear. We did it first. The Tu-144 was the first to fly supersonic with passengers, the first to reach Mach 2, the first to touch the edge of space in commercial service. It was fast. It was powerful. It was Soviet. But beneath the triumph were cracks, literal and figurative. The engines were notoriously fuel-hungry, limiting the range and increasing operational costs dramatically. Maintenance was difficult and required specialized crews. Spare parts were scarce. Safety concerns loomed constantly. The infamous crash at the 1973 Paris Air Show, caused by a combination of pilot error, last-minute maneuvers, and possible interference by a French Mirage jet sent to spy on the aircraft, resulted in the deaths of 6 crew members and 8 civilians on the ground. The footage, widely broadcast across the globe, stained the reputation of the Tu-144 permanently. It wasn't just a crash, it was a blow to the image of Soviet superiority. Still, in the aftermath, the Soviets doubled down. They modified the aircraft, refined the engines, and built an upgraded version, the Tu-144D, with improved safety, extended range, and reduced noise. But the damage was done. Western carriers weren't interested, and even Aeroflot, the Soviet national airline, only used the aircraft for a brief period between Moscow and Alma-Ata, a domestic route far below its potential. Passenger complaints were frequent, delays were common, and the cost to operate the Tu-144 far exceeded its commercial benefit. By the time the Concorde entered full service, flying from London and Paris to New York with luxury service and reliability, the Tu-144 was already fading into history. Only a few of the aircraft were ever built, just 16 in total, including prototypes and test models, and fewer still flew regularly. Yet, its legacy lived on in surprising ways. In the 1990s, long after the Soviet Union had collapsed, a strange collaboration formed between Russia and NASA, where an upgraded Tu-144 was leased to the American Space Agency to conduct supersonic flight research. Known as the Tu-144LL, or LL for Leteyevskaya Laboratoria, Flying Laboratory, the aircraft was refitted with modern instrumentation and used for a series of test flights aimed at developing the next generation of supersonic passenger aircraft. It was a bizarre twist of fate. Once a symbol of Cold War rivalry, the Tu-144 had now become a bridge between old enemies, contributing to the very future it once raced to define. Today, you can still find surviving Tu-144 standing silently in airfields, museums, and aviation parks across Russia, their massive frames frozen in time, their canards still folded tightly against their noses like resting wings. Some are open for public tours, allowing curious visitors to step inside, touch the steel walls, peer into the cockpit, and imagine what it must have been like to sit in a seat traveling at twice the speed of sound. The control panels remain intact, yellowed paper checklists still hang from dashboards, and faded warning labels in Cyrillic remind guests that this was once a living machine. Pilots who flew the Tu-144 described the experience as exhilarating but terrifying. Every takeoff felt like a leap into the unknown. Every landing was a high-speed ballet between metal, air, and instinct. The aircraft demanded respect, and sometimes submission. It wasn't just a machine to operate. It was a force to be reckoned with. In many ways, the Tu-144 was too much, too soon. It arrived before global air traffic infrastructure could support it, before maintenance systems could keep up with its needs, before the science of supersonic efficiency could match the dream. But that doesn't diminish its significance. If anything, it cements the Tu-144 as a daring experiment in the history of aviation, a glorious, flaming arrow shot across the sky in defiance of gravity, politics, and possibility. It dared to challenge the West, dared to chase Concorde, and dared to dream beyond limits. Even now, engineers designing the next wave of supersonic and hypersonic aircraft look back to the Tu-144 for lessons in aerodynamics, propulsion, risk, and resilience. But to truly understand what made the Tu-144 both a masterpiece and a cautionary tale, you have to go deeper, into the narrow corridors of Soviet command, where decisions weren't just about science, but about message control and national dominance. Inside those rooms, the Tu-144 was more than a jet. It was a flag flying at Mach 2, a challenge hurled at the West with every decibel of its thunderous engines. The Soviet leadership wasn't concerned with passenger comfort or economic feasibility. They wanted headlines, speed records, and the global spectacle of a red star streaking across the stratosphere. That urgency filtered down to every level of development. Engineers were pressured. Test pilots were sent into the air with prototypes barely out of fabrication. It was fast and brutal, with innovation born not just from brilliance, but from sheer necessity. The result? An aircraft that could do things no other commercial plane had ever done, and yet one that never found peace in the skies. Even within the Soviet Union, the Tu-144 was treated like a delicate relic rather than a routine airliner. Pilots were hand-selected, often from the military, and given months of specialized training. Maintenance teams needed special certification just to handle its engines. Each flight was an event. Each takeoff monitored closely by ground crews ready to respond to anomalies. And there were many. Fuel pumps failed. Avionics glitched. Cabin pressurization issues emerged at high altitudes. The titanium skin would sometimes expand and warp slightly from heat stress, causing panels to stick or vibrate mid-flight. In-flight noise reached up to 90 decibels inside the cabin, louder than a lawn mower. And unlike the Concorde, which had refined systems for everything from air conditioning to cabin altitude, the Tu-144 support systems felt more like military hardware. Functional but unforgiving. But behind those aluminum walls were stories few people ever heard. Flight attendants who memorized emergency procedures more often than safety briefings. Passengers, diplomats, elite scientists, high-ranking officials who flew not for comfort, but for status. They were the chosen few, flying aboard a technological beast that few dared to question. They dined on Soviet fare while flying higher than any commercial plane in the world. Their conversations sometimes drowned out by the screaming engines, their faces often illuminated by the surreal, bluish light of cruising above 60,000 feet. And still, no matter how surreal it felt inside, the costs outside were stacking up. The program bled resources. It took thousands of engineers, enormous financial backing, and infrastructure far beyond what Soviet civil aviation could sustain. The fuel costs alone were staggering. Each flight burned through specialized fuel at such a rate that just a few trips could offset the operating budget for other regional routes. And worse, it was limited in where it could fly. Sonic booms restricted it to mostly overland routes within Soviet borders. Its range barely extended beyond 3,000 miles. The Concorde flew transatlantic. The Tu-144 barely made from Moscow to Kazakhstan. And still, the Soviet Union pushed forward. They knew that retiring the aircraft would send a message of failure to the world. And so they kept it flying, even when logic said otherwise. But the final blow didn't come from the West. It came from within. On May 23, 1978, during a test flight from Moscow, a Tu-144 suffered a catastrophic failure. The aircraft was returning from a long-range mission when a fuel pump failure led to an onboard fire. The crew attempted an emergency landing, but the aircraft broke apart on approach. 2 of the 6 crew members died. This was not just another incident. It was the last straw. Confidence evaporated. The aircraft was grounded. All remaining Tu-144 passenger flights were canceled indefinitely. The dream had come crashing down, not in a blaze of glory, but in a whisper of bureaucratic decisions and shifting priorities. But the Tu-144 story didn't end there. Even in death, it had purpose. Throughout the 1980s and 90s, the airframes were used for research. Some became static training platforms for engineers and pilots. Others sat in military testing ranges, used to experiment with supersonic systems. But the most bizarre resurrection came in the mid-1990s, when the world had changed and former enemies found themselves shaking hands. NASA partnered with Russia to revive the Tu-144 for a joint research project aimed at exploring future supersonic passenger travel. The aircraft, redesignated Tu-144LL, was completely overhauled. Its engines were replaced with quieter, more efficient Kuznetsov and K-321s, the same used on the Tu-160 Blackjack bomber. The flight deck was retrofitted with Western instrumentation, and for a brief period, this Cold War relic once again took to the skies, this time in the name of cooperation. The Tu-144LL made several research flights between 1996 and 1999, gathering data on shockwave behavior, fuel efficiency, and cockpit ergonomics at high speeds. Ironically, it became more useful to U.S. aerospace research than it ever was to Soviet commercial aviation. And when the final flight was complete, it was quietly retired, this time for good. The airframe was parked in a hangar, dusted off only for museum visitors or the occasional documentary crew. But its spirit lived on. Engineers from Boeing, Lockheed Martin, and even private aerospace startups poured over the Tu-144LL data, using it to design the next generation of fast, efficient airliners. Though no supersonic airliner has flown commercially since the Concorde retired in 2003, the whispers of its return are growing louder, and each whisper carries echoes of the Tu-144. Today, as we stand on the edge of new breakthroughs in hypersonic technology and ultra-efficient propulsion systems, the legacy of the Tu-144 feels more relevant than ever. Aircraft like the Boom Supersonic Overture or NASA's X-59 quiet supersonic transport wouldn't exist without the groundwork laid by bold pioneers who dare to fly faster than sound. And while the Concorde often gets the spotlight, it's the Tu-144 that deserves credit for going first, flawed, ferocious, and unforgettable. Walk into any Russian aviation museum, and you'll see it there, nose down, canards out, standing tall like a monument to ambition. You can step inside, look out those tiny, square windows, run your hand along the now silent cockpit console, and for a moment, feel what it must have been like to be part of something extraordinary. You're not just stepping into a machine. You're stepping into history, into the heartbeat of a nation that once dared to outpace time itself. The seats may be empty now, the engine's cold, but the Tu-144 still speaks. It tells a story of speed, of sacrifice, of rivalry and redemption. It tells us that sometimes greatness isn't measured in miles flown or profits earned, but in the courage to try, to take off when others doubt you, to fly when others fear. The Tu-144 flew for less than a decade, but its shadow stretches across generations. It is a chapter in aviation no one can ignore, a supersonic icon born of steel and fire, tempered by tragedy, and immortalized in the dreams of those who refuse to be grounded. Whether admired for its ambition or analyzed for its failures, the Tu-144 remains one of the most fascinating aircraft ever built. It was too loud, too fast, too soon, but it was also too bold to be forgotten. And now, as the dust of history settles around the broken wings of the Tupolev Tu-144, we ask the question that echoes of the vast hangars of aviation history. Was it a triumph of engineering, or a tragic monument to haste and hubris? The answer, like the aircraft itself, is complicated and fierce. The Tu-144 wasn't just a machine. It was a Soviet dream cast in titanium, burning across the sky like a fiery declaration that the USSR could match and surpass the West. It was never meant to simply carry passengers. It was designed to carry prestige. And for a brief moment in time, it did. It thundered past Mach 2. It broke barriers. It flew higher and faster than anything in commercial use. But behind that velocity was a price no one could sustain. Not engineers, not pilots, not passengers, and certainly not the budget books of Aeroflot. The Tu-144 was an achievement born out of necessity, not commercial vision. Where Concorde had the benefit of collaboration, long-term investment, and a focus on operational viability, the Tu-144 was forced to sprint through its evolution, fueled by Cold War urgency rather than sound design. And that contrast between a bird bred for endurance and one forged for a single roaring lap reveals everything. The Concorde, though also eventually grounded, flew regularly for over 2 decades, serving thousands of passengers with an experience of luxury and reliability at supersonic speeds. The Tu-144, by contrast, carried passengers for less than a year, riddled with technical issues, stifled by operational limitations, and abandoned when it became clear it could not achieve what propaganda had promised. And yet, for all its flaws, the Tu-144 holds a kind of sacred place in the chronicles of aerospace innovation. It was ahead of its time and out of its depth all at once. A machine built to race ahead of a world that wasn't ready to follow. But let's not forget what the Tu-144 did give the world. It provided priceless data on high-speed flight, thermal resistance, supersonic stress behavior, and delta-wing aerodynamics. The knowledge gained from its short career was funneled into countless military and research aircraft that followed. In fact, its Canard Delta configuration, once dismissed as experimental, has since become standard in various fighter jet designs. The Eurofighter Typhoon, the Dassault Rafale, the Chengdu J-10, all carry the DNA of the Tu-144's unique layout. Its contribution didn't stop with aircraft. Its research flights with NASA provided information critical to shaping the next generation of quiet supersonic transport aircraft like the X-59 KSST, which aims to overcome the very issues the Tu-144 suffered from: noise, range, and efficiency. So when we look to the skies in the coming decades and see commercial jets cruising faster than sound again, don't be surprised if those wings carry the ghost of the Tu-144 somewhere within them. And now, let's take one last walk through the machine itself. Starting outside, the aircraft stands enormous, with needle-sharp nose and a length longer than a Boeing 757. The front canards extend outward like the arms of a soaring hawk, used only during takeoff and landing to stabilize the airflow across the wings and help manage the extreme pitch behavior at low speeds. These small, retractable wings give the Tu-144 its unmistakable silhouette, one that seemed ripped from the pages of science fiction when it first debuted. And then there's the nose, drooping downward in its iconic droop snoot design, much like the Concorde, allowing pilots to see the runway during taxi and landing phases. It wasn't a gimmick. It was necessity, dictated by the sharply inclined cockpit that would otherwise block visibility during low-speed operation. The titanium-reinforced undercarriage looks brutish and muscular, built to absorb the force of high-speed landings and sudden deceleration. Step inside, and the contrast between cutting-edge and crude becomes instantly apparent. The cabin, though pressurized, felt more like a Soviet train car than a luxury airliner. Rows were tight. Seating was utilitarian, and noise was unrelenting. There were no whisper-quiet engines here, just the growling roar of four Kuznetsov K, 144 afterburning turbofans positioned at the rear, pumping out raw power that vibrated to the floor panels. Passengers had to shout to speak. Headphones were sometimes issued not for entertainment, but for silence. The overhead luggage compartments were minimal, and the windows, while iconic, were small and oddly shaped, squared off and flat, due to pressure concerns at cruising altitudes. The cockpit itself, though surprisingly spacious, was a wall of analog dials and thick metal switches, most labeled in Cyrillic, many wrapped in industrial metal sheathing. There were no fly-by-wire systems here. It was brute mechanical force guided by exceptionally trained hands. Pilots didn't just fly the Tu-144, they fought it. Each takeoff required a delicate dance of throttle, flaps, canard extension, and nose angle control. And at cruising speed, the aircraft handled like a dart, ultra-stable in high-speed flight, but wildly temperamental below Mach. Navigating descent and approach required near-military precision, and even then, landings were described as rough, shaky, and unpredictable. But still, it flew, and when it did, it turned heads, broke windows, and rumbled cities beneath it. It was impossible to ignore. And maybe that's the lasting legacy of the Tu-144. It dared be loud. It dared to be fast. It dared to reach into the unknown and scream through it, daring anyone to follow. And though its flame burned brief, it burned bright enough to leave a mark on every jetliner, every test flight, and every blueprint since. So now, decades later, when we watch grainy footage of that silver spear hurtling through blue skies with a trail of white fire, we're not just watching a machine. We're watching a promise that we are capable of more, that the sky is not a limit, but an invitation. That boldness, even when it fails, writes a story worth telling. The Tu-144 was not perfect. It wasn't practical. It didn't make money. But it made history. And that alone secures its place as one of the most fascinating, fearless, and unforgettable aircraft ever to grace the skies. It was the fastest commercial aircraft in the world. It was the first to break the sound barrier with passengers aboard. It was the only plane to make even the Concorde look over its shoulder. And now it sits, not in shame, but in glory, retired, respected, and revered by those who still believe in speed, in audacity, and in reaching beyond the possible. In the end, the Tu-144 didn't fail. It simply arrived before the world was ready. And maybe that's what makes it legendary.